Remember when Einstein said light is a particle? He accidentally discovered a whole new field of physics which he thought is just a giant hoax. Quantum mechanics. This stuff is crazy. Another German guy called Max Planck said, yes, Einstein, you're right. Light does come in tiny packets. Actually, all energy comes in tiny packets, or quanta. Want to know where an electron is inside an atom? It's here, and there, and everywhere at the same time, actually. That's a superposition. It's not in one state, it's in multiple states at once. At least until you measure it. Then it chooses one cozy spot to be in. Schrödinger gave us an equation that gives you a probabilistic model of where you can find it if you were to measure. You can imagine this as a cloud, and the denser it is, the more likely it is for an electron to be there. But still, where exactly it will end up once you measure it is random. Speaking of observing particles, they're also super sensitive about their private data. Look at these two images of a flying ball. In one, you can clearly see where the ball is, but not in which direction it's moving, and in the other, you can see where it's moving and approximately how fast, but not where exactly it is at the moment. That is essentially Heisenberg's uncertainty principle. You can never know both the exact position and the exact speed of a quantum particle at the same time. Okay, let's recap. A small thing can be a particle and a wave at the same time, and when we try to look at them, weird stuff happens. But you know what? It gets even weirder. Think back to the double slit experiment. We know that a light beam acts as a bunch of waves and we get interference. But here's the weird thing. Even if you send individual photons after sending enough of them and detecting where they end up, you get interference. Like, how can that be? What did a single particle interfere with? Well, we think it interfered with itself because it acted as a wave and went through both slits at the same time. That's a superposition. Okay, well, let's just measure which slit it goes through. Yeah, that's not gonna happen. Once you start measuring which slit the photon goes through, it stops acting like a wave and the interference pattern disappears, as every particle chooses just one of the slits to go through. Sounds kinda suspicious to me.